about the ratio and the root test. The ratio test goes like this. Let AN be a series, and let the limit as n approaches infinity of a sub n plus 1 divided by a sub n equals to rho. Ratio test says that if rho is smaller than 1, then the series converges absolutely, and if rho is bigger than 1, then the series diverges, and if rho is equals to 1, then the test is inconclusive. Alright, let's apply the ratio test to the following examples. Suppose I wanted to find out if this series converges. So we have the sum as n goes from 1, actually it goes from 0 to infinity, 2 to the n plus 5 divided by 3 to the n. We're going to apply the ratio test. We're going to find the limit as n approaches infinity of a sub n plus 1 divided by a sub n, and as the value. This is the limit as n approaches infinity of 2 to the n plus 1 plus 5 divided by 3 to the n times 3 to the n divided by 2 to the n plus 5. Okay, this is equals to 1/3, or the limit as n approaches infinity of 1/3 times 2 to the n plus 1 plus 5 divided by 2 to the n plus 5. 1/3 is because this 3 to the n cancels with this is 3 to the n plus 1 right here, to cancel with the n. This is the limit as n approaches infinity, 1/3, and then to dividing everything by 2 to the n, we get 2 plus 5 over 2 to the n divided by 1 plus 5 over 2 to the n. So because this goes to 0 and this goes to 0 as n approaches infinity, we get 1/3 times 2 over 1, and therefore we get 2/3. Since this is less than 1, this series converges absolutely by the ratio test. Okay, next example, let's take a look at this series. So we have the sum as n goes from 1 to infinity of 2n factorial divided by n factorial times n factorial, and we want to see if this series converges or diverges. So we're going to apply the ratio test. I'm going to get the limit as n approaches infinity of a sub n plus 1 divided by a sub n, and as the value, this is the limit as n approaches infinity of 2n plus 2 factorial, that's by putting n plus 1 for n plus 1 factorial, n plus 1 factorial, times n factorial divided by 2n factorial. Alright, this is equals to the limit as n approaches infinity to n plus 2 to n plus 1 times 2n factorial divided by n plus 1 times n factorial, n plus 1 times n factorial, and then we have n factorial, and 2n factorial. So then you can see that this n factorial cancels with this. This is 2n factorial. The 2n factorial, this cancels with this, and then this cancels with that. Alright, so then we get the limit as n approaches infinity of 2n plus 1. You can factor out a 2 from there, and then 2n plus 1. Like this, n plus 1 times n plus 1. This cancels with that. So we get the limit as n approaches infinity of 2n plus 1, like this, divided by n plus 1. This is the limit as n approaches infinity of 4n plus plus 2 divided by n plus 1, and this is the limit is equals to 4. So because this is bigger than 1, this diverges by the ratio test. Okay, there is this root test that says let an be a series and let the limit as n approaches infinity of the nth root of an in absolute value be equal to some number rho. Same properties. If rho is smaller than 1, then an converges absolutely. The 2, if rho is bigger than 1, then an diverges. And 3, if rho is equals to 1, then the root test is inconclusive. And let's take a look at the following two examples. So, suppose we wanted to know if this series converges or diverges. N squared divided by 2 to the n. The root test goes like this. We're going to take the limit as n approaches infinity of the nth root of an in absolute value. This is the limit as n approaches infinity of the nth root of n squared divided by 2 to the n. But this is the limit as n approaches infinity of the nth root of n squared divided by 2 to the nth root of that. And then this is the limit as n approaches infinity of the nth root of n squared. That's what the top becomes, and the bottom, the n and the n cancel, so we get 2. The limit of the nth root of n is equals to 1, so we get 1, and then we square it, and divide by 2. This is 1/2. Because this is less than 1, this converges absolutely by the root test. Another example would be this one. the sum ascent goes from 1 to infinity of 2 to the n divided by n cubed. So again, we're going to take the limit as n approaches infinity of the nth root of a sub n in absolute value. This will be the limit as n approaches infinity of the nth root of 2 to the n divided by n cubed. And then this is the limit as n approaches infinity of the nth root of 2 to the n divided by the nth root of n cubed, and this is equals to the limit as n approaches infinity of 2 divided by the nth root of n cubed, like that. And when you take the limit as n approaches infinity of 2, so then well, you get from here 2 divided by 1 cubed, because the limit of the nth root of n is equals to 1, so this is 2, which is bigger than 1, so then this series diverges by the root test. Okay, these are the ratio and the root tests. Thank you very much.